Yesterday in class, you worked through homework 6A with your team. In doing that activity, you noticed that there were patterns in how the elements combine. So, for example, 1A and 7A elements always combine in a 1-to-1 ratio, while 2A and 7A elements always combine in a 1-to-2 ratio. We also recognized in doing that activity that charge must add up to 0 for a compound. Thus, we discovered that elements in certain columns of the periodic table form ions with specific charges. So based on your work yesterday, and specifically questions 6 and 7 on homework 7A, we discovered that elements in the 1A column always form ions with a positive 1 charge when they're in an ionic compound. Elements from the 2A column form ions with a positive 2 charge. Elements in the 3A column form ions with a positive 3 charge. We did not look at any 4A elements because typically elements in the 4A column don't participate in ionic compounds, only in covalent compounds. So we're just going to not worry, there's no patterns really with 4A. In 5A, they will typically have a negative 3 charge. In 6A, a negative 2 charge, and elements from column 7A have a negative 1 charge. Notice we have skipped all of the elements in the middle, and we have also skipped column 8A. Column 8A are called the noble gases, and they don't participate in reactions much. And all of the elements in the middle section, which I'm circling here, these metals don't follow a pattern as well, so we're going to deal with them a little bit later in the chapter, because it's not as nice and easy when they don't follow a pattern. So based on our work yesterday, a specific metal and a specific nonmetal will always combine in the same simple whole number ratio. So like we saw, 1A and 7A elements always combine in a 1-to-1 ratio, for example. They combine in this way because an ionic compound is going to make a compound where the charges add up to 0. So we're going to look at a couple of examples. The first example we're going to look at is calcium and chlorine. If you locate those elements on the periodic table, you will see that calcium is in column 2A, which means by our patterns it's always going to have a positive 2 charge. Chlorine is in column 7A, and so it will always have a minus 1 charge. So you can think about this in a couple different ways. You can look at the patterns that you have on homework 6A and see what ratio they combine in, or you can think about the charges adding up to 0. So I prefer the charges adding up to 0 way, but you can also refer back to homework 6A. If you have a calcium atom or ion with a positive 2 charge, and a chlorine atom with a minus 1 charge, right now those charges, positive 2 and minus 1, do not add up to 0. To get them to add up to 0, we're going to need a second chlorine ion. Now, the positive 2 and the 2 negative 1s, positive 2 minus 1, add up to 0. So the formula for this compound is CaCl2. This 2 indicates that there's 2 chlorine atoms, and not writing a number here indicates that there's 1 calcium. Your homework's going to ask you to draw this as a particle diagram. That's just going to put circles around each of these to remind ourselves that they're each representing an actual particle. Another way you could do the same problem is look back at 6A and see that a 2A and a 7A element combine in a 1-to-2 ratio, and you would get the same result either way. Let's look at a second example, aluminum and oxygen. Aluminum is in column 3A and will always have a positive 3 charge. Oxygen is in column 6A and will always have a negative 2 charge. So if we look at a picture and try and figure out how we can get those charges to add up to 0, I just start by simply assuming the simplest case, then we have 1 of each. 1 aluminum and 1 oxygen. Right now, positive 3 and negative 2 do not add up to 0, so that's not going to work. So I'm going to add another oxygen, which will give me another negative 2. Now I've got positive 3 minus 4, That doesn't add up to 0. I need more positives. So I'm going to add another aluminum. Now we've got positive 6 from our 2 positive 3s, minus 2, or minus 4, which still does not add up to 0. So I'm going to add one more negative oxygen atom, O minus 2. So now we finally have positive 6 and negative 6, which adds up to 0. The formula for this compound will be Al2O3. And if you go back to homework 6A and check yourself, you should see that a 3A and a 6A element combine in a 2:3 ratio. So you can use the charges or the patterns to figure it out. One other additional note that is of interest here, ionic compounds are held together by an ionic bond. So the ionic compound is the whole substance. The ionic bond is the connection that holds them together. So covalent compounds, we've been focusing on ionic compounds in the first part of these notes and in homework 6A yesterday. But what about covalent compounds? When two or more nonmetals combine, we've got several atoms that all have strong positive cores. So each atom has a strong attraction for the electrons. We don't have a situation where one atom can attract electrons away from another atom. And as a result, no ions are formed. So each atom has a strong electron. What happens instead is, since both atoms attract the electrons strongly, the electrons are actually shared between the atoms. The way that I like to remember this is ionic compounds are made of ions, positive and negative charged particles. Covalent compounds, the prefix co means with, so they work together to share electrons. So covalent compounds are held together by a covalent bond, and a covalent bond is a mutual attraction for shared electrons. So again, covalent compounds are held together by a mutual attraction for shared electrons, which is called a covalent bond. The rest of the day today, you're going to be working on practicing predicting the formulas for ionic compounds. Ionic compounds are a little bit more interesting because they combine in set patterns. Covalent compounds can combine in a lot of different ways, so there's not patterns that we can practice. So your homework again is going to be working on using the patterns that we saw yesterday in 6A to predict the formulas for other compounds that are made out of ions.